Welcome! Today we'll learn how to find the equations of the tangent and normal lines for the function y equals x cubed minus 3x plus 2 at the point 2 comma negative 2. Let's break this down into steps. First, we need to find the derivative of our function. Using the power rule and constant rule, the derivative f prime of x equals 3x squared minus 3. Step 2, we'll find the slope of the tangent line by evaluating f prime at x equals 2. Plugging in x equals 2, we get 3 times 2 squared minus 3, which equals 9. Step 3. Now we can find the equation of the tangent line using point-slope form. Y minus y1 equals m times x minus x1, where m is our slope of 9, and our point is 2 comma negative 2. Simplifying this equation, we get y plus 2 equals 9x minus 18, and finally, y equals 9x minus 20. Step 4. For the normal line, we need to use the fact that it's perpendicular to the tangent line. The slopes of perpendicular lines multiply to give negative 1. So if our tangent slope is 9, our normal slope will be negative 1/9. Using point-slope form again with slope negative 1/9, and our point 2 comma negative 2, we get y plus 2 equals negative 1/9 times x minus 2. Simplifying, we get y equals negative 1/9 x minus 14/9. Let's visualize this graphically. In this graph, we can see our original function in blue, the tangent line in green, and the normal line in red, all intersecting at our point 2 comma negative 2. Notice how the tangent line touches the curve at exactly one point, while the normal line is perpendicular to it. To summarize, we found that the tangent line equation is y equals 9x minus 20, and the normal line equation is y equals negative 1/9 x minus 14/9. We found these by using derivatives and the relationship between perpendicular lines.